Hi folks, Mr. Long here. We're going to go back to grade 9 and we're going to graph equations in a line. Now probably you remember these kinds of equations, y equals mx plus b. But today we're going to graph in this form, y equals mx minus z. And given that you've already graphed quadratics, it kind of makes sense that we would do this. Now y equals mx plus b, you know, is slope, right here, m, and then y-intercept form. On the other hand, this form here, y equals m bracket x minus z, is slope and z is the x-intercept of the line. So what's involved here is you always have to factor out m. And even if it's a 1, I'm going to encourage you initially to factor it out. So let's take a look at an example here. So let's see. Y equals 2x minus 6. So I don't think, can we zoom in on that? Let's see, yeah, we'll zoom in on that. So let's go ahead and factor that. So if I factor out the 2, that means I'm dividing everything by 2 on the right side. So y would equal 2, and then what I've got to do is graph, I've got to factor out the 2. 2x divided by 2 is x, and then I've got this negative 6 divided by 2 is negative 3. And then we know that so now we've got this equation, y equals 2 bracket x minus 3. Well, I think we remember that if y equals a times b, the only way you're going to get this y equal to 0 is if either a is 0 or b is 0. So when I look at this, I've got a 2 here. Can that 2 ever be 0? No, it's 2. What about this part right here, this factor, x minus 3? Can that ever be 0? Well, that can be 0 if x is 3. So if x is 3, I get 3 minus 3 here, which is 0, and then 2 times 0 is 0. And then y equals 0. So there's 5 up, 4 up, 3 up, 2 up, 1 down, 2 down, 3 down, 4 down, 5 down. So 0 is along this axis. So if x equals 3, y equals 0. So let's go ahead and mark that. So right here at 3, I've got a point on that line, which is the x-intercept, and then 2 over 1 means a rise over run of 2 over 1. So I go up 2 over 1, up 2 over 1. But you know what? Doesn't really even matter. I'm not really concerned with that. I just want to graph the straight line through here. Okay, then the other part of this question is, what does x equal when y is greater than 0? Well, when is y greater than 0? Or when is y above the x-axis? That's what that's asking. So I'm going to highlight the part of the curve where it's above the x-axis. Right there. Okay, it's that part of the curve. Okay, so y is greater than 0 if x is to the right of 3. So in other words, when x is greater than 3. Okay, when x is greater than 3, to the right of 3. That's when y is above 0. Okay, these inequalities in 2 dimensions are really incredibly important, and you're going to have to learn about this stuff. Let's look at another example. Now this one is very similar. The way we're going to write this is y equals, now if you look at this equation, x minus 3, it's just 1 bracket x minus 3, right? There is no number in front of the x. So again, what's the x-intercept? Well, it's at 3. And in this case, does it really matter what the y-intercept is? Well, I know it's negative 3, right? Automatically, so I can just draw that if I want. And I know it's sloping up at a rate of 1 over 1. Then again, the question is, y is greater than 0. So I want to figure out all the x values when y is greater than 0. So I'm going to highlight all the values on that line that have a y value that's greater than 0? Well, again, it looks like it's only to the right of 3. So that's when x is greater than 3. Okay? So the whole idea here is that we're going to graph these lines and solve this inequality. And we are going to need to do this so we can graph parabolas properly later on, and square root functions and reciprocal functions and exponential functions and trigonometric functions, all kinds of functions. It's important to be able to do this. So now I'm just going to do a few more examples, but do them a little bit quicker. Okay, so got an example here. Y equals negative x plus 4. So again, we know that that means y equals negative 1x plus 4, but I want to common factor out the negative 1, and then I'm dividing everything by negative 1. So that's going to be x minus 4. And I think we know that this negative 1 here means the slope is actually negative 1 over 1. Should do that in blue. Negative 1 over 1. So it's down 1, right 1. Rise over run. Down 1, right 1. So it's a negative slope. And then where's the x-intercept going to be? If x minus 4 has to be 0, x is equal to 4. Okay, so if we look at this case, now I know the slope is negative, right? It's sloping down. And if I look at just this equation, it's pretty easy to see that plus 4 is the y-intercept, even though that doesn't really matter in our case. We're not worried about that. So now, what is the x-intercept? Well, it looks like the x-intercept is right there at 4. Okay, but when is y greater than 0? And we need to solve that inequality. Well, I'm going to highlight the part when y is greater than 0, so it's all of these values. Well, notice now that it's only to the left of 4. So that means that x has to be less than 4. Okay, so let's look at that symbol there. So look at this. Right there, x has to be less than 4. I'm going to write that over here. X is less than 4. Okay, because it's to the left of 4. X is less than 4. Okay, that's when y is positive. Okay, let's try a few more. I think x plus 2 is going to be a pretty easy one, but we'll try that one. Okay, let's try that one. So again, let's write it in slope x-intercept form. So there's a 1 out front, and it's just going to be x plus 2, which is very straightforward. So what makes that bracket worth, that factor, bracket, parentheses, set of parentheses, what makes that worth 0? So y can equal 0. Well, x equals negative 2. So if I go here, that means there's an x-intercept here, there's a y-intercept at 2, and I can just draw the line through. Okay, there's my straight line with an x-intercept of negative 2 and a y-intercept of 2. And then I want to make sure that y is greater than 0. So I'm going to highlight the part that's greater than 0. Okay, so when does that occur? To the right of 2, or when x is, to the right of negative 2, when x is greater than negative 2. Okay, x is greater than negative 2 results in y being above the x-axis, or y greater than 0. Okay, so all we're doing here, graphing the line, do the inequality. Graph the line, do the inequality. Okay. Negative x minus 5. Okay, we've got a new one to do. So in this case, I have to factor out the negative 1. Bracket x plus 5. So again, what makes that bracket worth 0? So I get a y value of 0. Well, x has to equal negative 5. So I go all the way over here to negative 5. And I know it's sloping downhill, so I can see, and also I know the y-intercept is negative 5. So there's my line like that. Again, it doesn't matter if you get the y-intercept accurately. In this type of question, we're focusing on graphing the x-intercept, not the y-intercept. So once again, let's highlight the part where y is greater than 0, to the left of negative 5. So in that direction. Okay, to the left of negative 5 is when y is greater than 0, or when the line is above the x-axis. Okay, so x is less than negative 5. And we have one more example to do, and that's it. Okay, y equals negative x. Well, I don't know if, do I really need to factor this negative out? I suppose I can. Negative, and then in brackets x, or another way to think of that is negative in brackets x minus 0, right? Because if I don't have anything there, it's x, it could be plus 0 as well, but that keeps it in our form. Negative bracket x minus 0, so that means the x-intercept is at 0, or at the origin. I also know that this is sloping down because of the negative sign right there. So this graph is going to look something like that. Okay, so let's highlight the part that's greater than 0. Okay, that's the part that's greater than 0. The y value is greater than 0. So I'm allowed to have any x value that's to the left. Okay, so x is less than, whoops, so x is less than 0. Okay, so now what I'm going to ask you to do, folks, is to really quickly graph these, please, and solve the inequality. Okay, and I do have, you know what I'll do? I'm going to leave that right there for you to do, and I'll actually quickly do the answers right here for you. So on the first one, x is going to be greater than negative 5. And the second one, x is going to be less than 1. The third one, x is going to be less than, sorry, I'm thinking through this as I'm doing it. Less than negative 2. And for this one, x will be greater than 5. And for this one, x is greater than 0. So that goes there, that goes there, that goes there. So those are your answers. So in fact, what you could do is pause the video right now and or take a screen capture of your screen right now and graph those properly, please, if you would, and write down the inequality. Okay, so I know this is grade 9 level work, but however, I have noticed in the past that sometimes kids have forgotten a lot of things from grade 9, and graphing the straight line is probably, being able to graph and work with the straight line is probably the most important understanding of concept that you need to be successful in grade 11 and 12 in terms of going back and making connections. Okay, so please do this. Please take the 10 minutes it's going to take to do this, and we'll go on from there. Have a great day.